So about a while ago, there was a news article that was published, and I don't know if Anton Petrov actually covered this before, so I might be a little late to this, but apparently there are now 6 to 20 trillion galaxies for every 93 billion light years within the observable universe. Now, so basically what this means is if it's 6 trillion, it's basically every light year there's somewhere between like 64 or maybe it's 62. I think it's 65. Last I checked, galaxies for every light year within that distance, which kind of doesn't seem like it makes sense. But then again, when you think of 20 trillion, it's actually 215 galaxies per every light year. But it's weird because this either makes no sense, or it's like the metrics that we have are, we underestimate what's out there, because you could have a bunch of galaxies right next to each other and either they collaborate but they're still two different galaxies until they completely merge into one, or they could be something far bigger than that. And even then, something to think about, it really just goes to show you that either way, we are underestimating how big a lot of these galaxies are, because we really we can't really accurately measure something that big. It's something beyond our understanding still, So if we really are counting this right, then when people say they have an idea of what 93 billion light years are, it's got to be even bigger than that, or maybe how many galaxies are inside of 93 billion light years, because one light year, if you don't know, is 5.88 trillion miles. But at the same time, if you think about a lot of the metrics that we think we know so far, everything's just measured differently. But everything seems to be, it's like a fluctuation. Once one thing's discovered and somebody has to go back and autocorrect something, what about everything else that we've discovered so far? And what does that mean? So basically, as far as the observable universe goes, we have discovered quite a bit, but, even then, we can say that we've gone as far as this, but we might not have detailed everything besides that. One thing that's really interesting to think about is when you think of like the observable universe and how many different things are out there, you might be surprised at how many other things you discover along the way. So within that 6 trillion galaxies, for example, you might not just discover how many different galaxies, or 20 trillion. You might actually discover how many other things are inside those galaxies, and how many like other planets, how many other moons, how many other asteroids or comets or etc. How many different elements there are, how many different kinds of, how big those galaxies are. Like even our galaxy was said to have been at least 100,000 light years, and that's still pretty big. But at the same time, though, it's like, then you hear like some people say that maybe a couple of years ago they were suggesting that it was like 1.9 million light years because they think they found the edge of it finally. And there's something about like where we're at, like depending on who you ask, some people believe we're at the very center of it, or near the center of it, like 25,000 light years away from it. But at the same time, though, there's some people that believe we're like near the outer edge of it. And that kind of is interesting to think about. Really, we don't really know where we're at, because the thing is, put it this way, as long as we have no understanding of like the circumference of our galaxy, we really truly don't know the diameter either. So, because if you don't know, simple math, a diameter is a straight line. And the circumference of that circle, you have to take the diameter of that circle and multiply it by 3.14, pi in this case. So if, in this case, if our galaxy was 1.99 light years, basically you would take that and times it by 3.14, and it's roughly, it's just under 6 light years in diameter. It's pretty big when you think about it. But at the same time, it does make you wonder, though, like that's just one galaxy. And that's even before you consider the Andromeda galaxy merging with it on its collision course. And then, what is that going to do for our galaxy and all the stars and everything that are inside of it? What is that going to do for, and like, what about the Andromeda galaxy? Like, how big is the Andromeda galaxy? You go back to like what people used to say about some of the stuff that we've discovered in the past. Like you have galaxies that are so far away but they look like they're so big though. And while yes, we do have like estimated formulas to be able to, kind of pinpoint like exactly how big the object itself is, but it's what is known as the illusion of distance. I mean, either the distance itself is further than what we have on record, or the object itself is so far away that it's actually bigger than how we're actually being able to read it, even with the best telescopes that can zoom in on it. And this has been a subject of debate for like hundreds of years. There have been scientists that have called it something different, but they've always implied that, space gives off that great effect in life. Everything in space is traveling so fast, and everything's traveling at such an alarming rate that it's faster than we can comprehend it. Now, if that is true, and if you want proof of this, for example, you can also try, like when the moon arises, for example, like some people believe there's a difference there. There's an illusion of distance between how it rises, because people believe it's not truly that close to the Earth. That's why you have people that say like you got like these super moons, for example, that you could see, but it's nowhere near that close to the Earth. It just gives off an illusion, and it's not like a reflection in the atmosphere. It's just giving off how that perception looks from that distance. So either one of two things is true. Either our eyes can't comprehend the reality we live in, hence, some people believe the universe is a simulation of some kind. Or at the same time, though, we really just don't understand how to measure stuff like this because it's so far away and traveling so fast. And by the time, and if you want another good example, I mean, if you've ever seen the moon, for example, in the telescope, you know that it's always constantly moving at such an alarming rate. And you don't have to have a telescope to see it in space. Obviously you can see it. But usually when there's a full moon, you can... it works even better because there's more light there. If you really stare at it long enough, you'll just start seeing it move. And that's not, but at the same time, though, you got to take into accountability the Earth's rotating in its own way, too. In a lot of ways, and if I got it right, the Earth is rotating in the opposite direction of which way the moon is traveling. Well, it's either one or the other. But if it's doing it the same way, because I don't know off the top of my head, it's definitely true that everything that we do see is out there, and it's definitely far more advanced than what we have on record. What's out there, we gotta like really mathematically go back and double check everything and make sure we can make sense of all of it before we can start really accurately saying that we know everything about our galaxy or even the galaxies that we have yet to discover, other dimensions, other metrics, and all these other discoveries. But it's interesting to think, though, so we can always just assume in a positive way that there's always more out there. So for every time, so like if it's really like 6 to 20 trillion galaxies, we can at least say on record right now that it's anywhere between 65 to 215 galaxies per light year that we're, expected to see. So within a vicinity of that, you would really see a lot of galaxies here and there. But at the same time, though, it's very possible that, it's even further than that, So maybe that distance might sound too close because there's galaxies out there that are just too big. Even our galaxy, for example, is at least 1.9 million light years, and that's obviously 1.9 million is times bigger than just 1 light year. So, it would be interesting to find a galaxy. If you ask me, it would be interesting to find a galaxy that's one light year and really just kind of see how small it is in comparison to like something as big as ours. But at the same time, I do believe, and I wouldn't be surprised, there's at least 6 to 20 trillion galaxies out there for like every 93 billion light years, and even more than that, because it just goes to show you that there's just so much out there that we don't see. And that's just how big it really is when you really think about it, how far apart these galaxies can really be. But how can so many things exist in such a smaller complex, though, is really the idea behind the whole thing.